স্যার ইউটিউবে কানেক্ট হয়ে গেছে। হ্যাঁ। Good morning, dear participants. We are going to start the session in another 8 minutes. Good morning, sir. Good morning, Professor. Good morning, dear participants. We are going to start the session in another 8 minutes.
Hello.
Yes, sir. Good morning.
Yes, good morning.
So we are going to start sharp at 11 o'clock.
Okay.
So how are you, sir?
Doing good.
Great. So yesterday night I had shared the material which you have shared with the participants, and I
Okay.
hope they have been able to connect with those things.
Sure.
Yeah. We shall start the session in another 2 minutes. Sir. So I think we should start the session.
Okay. Fine. I'll get started then.
So warm welcome, dear participants and Professor Kartike Bholar to the fourth day of the 5-day national workshop on research methodology. So we are here at the fourth day, and in the fourth day too, we have two important intriguing sessions. The first session would be conducted at from 11 a.m. to 1 p.m. and the topic of today's session would be structural equation modeling or ACM, and that session would be conducted by Professor Kartike Bholar. And after that, we are going to have a lunch break from 1 p.m. to 2 p.m. And the second session would be conducted from 2 p.m. to 4 p.m. And the topic for that session would be mediation and moderation analysis. And that session would also be conducted by Professor Kartike Bholar. So without further, delay,
বলার কন্ট্যাক্ট করলে তো হবে না আমাকে এখানে অ্যাড আপস কেন
please participants, please put yourself in mute. It's a humble request, put yourself on mute. So we are moving on to the first session, and in the first session we are going to
কিভাবে দিয়েছিস আমাকে
So in the first session we are going to talk about structural equation modeling, and for today's session we are going to have Professor Kartike Bholar sir, whom we had already introduced you in the last day, that is yesterday. So without further delay, I hand over the session proceedings to Kartike sir. Sir, the session is all yours.
Yeah. Thank you, Professor. So, okay. Can I get the host rights, please?
Yes, sir. I'm doing that. Yes, sir. It is done.
Yeah, okay. Thank you. Are you able to see my screen?
Yeah, sir.
Okay. Yes. Good morning, everyone. Yeah, taking forward from the yesterday's session, we had on exploratory factor analysis and then confirmatory factor analysis. This is going to be an extended session from the same. Uh, as we saw yesterday, that the first thing which we looked at was uh, whenever we have some constructs in place, we are looking at first checking out whether the measures which or the indicators of the respective constructs uh, are really measuring the constructs as we understand, right? So that's where the role of confirmatory factor analysis came in, particularly because there we check for the reliability and validity of the indicators of the constructs, right? Yesterday
ये
we
इसका
did
कपड़ा क्या है? आप यहाँ काम करते हो?
so yesterday we had established the validity of the constructs in focus. So in today's session, when I'm talking about structural model of structural equation modeling, so to be putting it in a right perspective, like structural equation modeling as usually starts from confirmatory factor analysis and then the structural analysis. And one of that aspects we have already seen yesterday, that is the confirmatory factor analysis. So today we'll be focusing on the structural analysis of structural equation modeling. Okay. So again, going forward with the yesterday's example, like if you had kept track of that, otherwise you can also look at the material which I have mailed you already, right? So let me just open the file which I had saved yesterday for the yesterday's work which we did. Right. So this is what I had done yesterday on JASP. So we carried out the principal component analysis. Just to have a quick summary of what we did yesterday, and then I'll take it forward from here. So we had considered 10 variables which were intending to measure 3 concepts, right? And as with reference to my paper, which we had looked at this particular model. So we had three factor structure where there were 10 variables or questions which were trying to measure these respectively, right? And this was the factor structure which we had got using the exploratory factor analysis using PCA, right? Yeah. So so each of this was information integrity, information security, and interface utility. So this is just for our reference, so that when I'm discussing structural model, you can appreciate what are those constructs and why we have related those constructs in that particular way, right? So information integrity, information security, and interface utility. So these were the factors which were obtained using the exploratory factor analysis through PCA, right? And then we ended up doing a confirmatory factor analysis where I was I differentiated between exploratory and confirmatory. In confirmatory, we consider these variables as indicators, whereas in exploratory factor analysis, they are like contributors, right? So the fundamental difference between a contributor and an indicator is that when it comes to an indicator, the error is vested with the indicator itself, right? So in a confirmatory factor analysis, as I was showing you the diagram, the indicators have a directed arrow towards them, whereas in a exploratory factor analysis, the contributors will set the direction of the arrow, right? So that is how there are two different things. So if you look at this part diagram, so you could see that a contributors, they set the direction, whereas indicators, the directed arrows will be towards them, because this is a reflective model, so where the constructs reflect in these particular indicators, right? So this is what we had done yesterday, just to set up the context. Now, when we talk about structural analysis, we are trying to see what is the directed relationship between the constructs. That means we are not going to deal individually with the variables, but once we have established that there are some constructs which have some indicators, we are going to now set up a relationship between the constructs itself, right? And that's where the structural analysis will come into place. So what is actually structural analysis? So structural analysis in a nutshell is nothing but testing of your hypothesis, which you have assumed between the constructs. Okay. So if I go back to my reference paper, so where do we exactly make a case for structural analysis is here, right? So whenever we draw the model, a research model, where we have introduced our constructs and that is a chain of directed arrows from one construct to other construct, we are trying to suggest that there is some kind of a relationship between those constructs, and mostly a directed relationship rather than a bidirectional relationship, right? So when I say directed relationship, what do we mean is like here, for instance, how this is suggesting is that we say hypothesis H1, it is suggesting a positive relationship between information security and information integrity, wherein the arrow itself is indicating that the dependent variable here is information integrity and the independent variable is information security. But now the only difference is that here, when the variable is a latent variable, or what we generally call as a constraint, right? So this is nothing but a directional relationship between two constructs. So H1 is depicting that. So positive perception of information security positively influences the favorable opinion of information integrity, right? So these were the ones which we had measured, and then we established the validity of those measures in the confirmatory factor analysis. Okay, so now this is what we are going to test in a structural model. Similarly, here we have another hypothesis suggesting that information integrity might be positively influencing the utility, right? So that is H2. And similarly, there is another, we are also trying to assess the direct effect of information security over utility, right? So you see, these are the different possibilities which we are testing in a structural model. Right. Now I'll be talking about this the H4 hypothesis a bit later, perhaps in the next session, where we would be discussing about mediation and moderation, because mediation or moderation for that matter in a structural equation modeling is a special type of structural modeling technique. So that so I'll deal with this in the next session when we talk about mediation and moderation in detail. Right. So for time being, let's understand this three hypotheses, H1, H2, and H3, which we are going to test using a structural model. Okay. So it looks quite simple to do a model specification of these. So because it's just that you need to set up your dependent variable, independent variables, and all those things, and then we are fine to go with the structural analysis. Now,
Sir, I got a question. Excuse me.
Yes,
what are
please.
constructs? Are they dependent variable or they're dependent variable? Suppose I got 4 independent and 1 dependent. So how do I know which is my construct?
Construct is a higher level thing. So, okay, let me give a bit of clarity between, because I might be interchangeably using this term variable and construct. Okay. Now, construct is basically the concept which we are trying to measure. Okay. So that's why we call them as a construct. Okay. When we say that there is a relationship between the construct, we are talking about those variables relationship which cannot be observed directly. Like when I say information security and information integrity, okay, or for that matter, interface utility, all of these are constructs. Why is it so? Because we are not in a position to measure them directly. They are also called as latent variables. Okay. So why it's called latent variables? Because they are not observed directly, but they are measured through some indicators. Right. So that's what we saw in our previous session, that when we say they are measured through indicators, so the indicators are the observed variables. So in this particular model, what you can understand clearly is that there are three constructs: information security, information integrity, and interface utility. Okay. All of these are also called as latent variables. Now, why they are called latent variables? Because they are not measured directly. That means I cannot just get one response and say that it is the response for information security. Okay. So then comes what are observed variables, or what we generally put in a questionnaire, right? So or we call them as items as well, right? So observed variables, items, or variables in a questionnaire, they all mean the same. Okay. That means you are directly measuring that through the customer's response, right? Now, in this particular thing, you can see that there are 10 such variables. So I said, when they say statement or items, these are 10 variables, observed variables, and 10 observed variables. They are also indicators of my latent variables. So how do we say that? Let's say the first 4 observed variables, they are the indicators of my latent variable information integrity. This is also called as a construct, right? So then we see that the next 3 observed variables are indicators of my construct or latent variable information security. and the other three, the remaining three variables are indicators of interface utility. Again, interface utility is also a constraint. Yeah. Now the question is, like as you put in, like whether they're dependent. Yes. So depending upon how you are specifying your structural model, that means your hypothesis, one can become a dependent construct or independent construct. So when I say here, for instance, if I only focus on information security and information integrity relationship, I can say that information security is my independent construct and information integrity is my dependent construct. Okay. But if I look at the relationship between information integrity and interface utility, information integrity becomes my independent construct and interface utility becomes my dependent construct. Now, of course, you might be wondering that can a particular construct be a independent construct and a dependent construct at the same time? Now, that's why to remove this confusion, there is a different term coined called as endogenous or exogenous variables. Okay. Now, typically, when we say endogenous variables, they are the ones where the directed arrow comes to them. Like for instance, if I say interface utility, it is an endogenous construct or a variable. Okay. So endogenous construct, why it's called an endogenous construct? Pure endogenous construct in sense that because everything is influencing it rather than they influencing anything, right? Whereas if you look at information security per se, it is a pure exogenous construct. In a sense, it has no directed arrow coming to it, but it's only bringing out a directed arrow from that. So here you can say that information security is an exogenous construct. Okay, because something where the arrow is exiting out, so that's why it's called exogenous construct. Now coming to information integrity, yes, it can be endogenous in the relationship between information security and integrity, but it can be exogenous in the relationship between information integrity and utility. So have I answered your question?
Yes, sir. You have answered the question. I got this another doubt.
Okay.
When we are telling exogenous,
I'm afraid I am not able to hear you.
variable or the endogenous variable that we are telling, are these variable are a moderator or mediators?
Okay. I think now the concept of moderator and mediator is just should not be taken up in a structural model in one sense, because see, of course, I am going to discuss this in detail in the next session about how do we understand what is a moderator and what is a mediator. Okay, so I'll definitely take up this question of what can be considered as a moderator or a mediator in the next session. However, to just immediately give you an answer to this question here, of course, it depends upon how you are putting the construct in a structural model, right? Now, that means if you're utilizing it only as a catalyst, then it might become a moderator. So I'll tell you what you mean by catalyst in the next session. So because since you asked this question here, so I'm just giving you an immediate indication that it depends. It really depends upon how you are positioning your construct in a structural model. So if you are positioning your construct somewhere in between a structural model, then possibly it can be a mediator. And if you are keeping it as a construct which is trying to influence a certain relationship between the existing other constructs, then it might turn out to be a moderator, right? So it really depends upon how are you positioning your constructs in a structural model, and that will make a moderator or a mediator. Okay.
Okay, sir. Thank you.
Yeah. Right. So yes, if you consider this particular model, there is a possibility of information integrity playing the role of a mediator, right? So that's why I've just kept that fourth hypothesis for hold. Okay, the fourth hypothesis, you can see that information integrity mediates the influence of security on utility, right? So it is a potential mediator according to this model. Okay, but why it is a mediator? Why can't it be moderator? I'll discuss that in the next session, right? So that the please hold to this question, and I'll definitely recall this question there, right? Okay. Now, the question is, how do we specify our structural model? Okay, so let's have my JISU open up. Now, when we have to specify in JISU, okay, there is a very simple way of specifying our structural models and even our conformative factor analysis models. Of course, in JISU, we have a provision of conformative factor analysis being done in this way, where we were placing the indicators of the respective constructs there. But, oh, sorry, I did I delete this? Oh, okay, accidentally. Anyway, just a minute. One minute. I think I opened the wrong file. Yeah, this one. Okay. Yeah. So let's say I have to establish a structural model now. So we just take up the SCM module. Now, this may not be there immediately if you have installed just now. So what you can do is in the plus sign, you can just check that SCM1, and automatically it will come on your interface, right? So in the JISU, you can do that. Right, and once it is done, so there's no further installation, it will automatically come there, right? So now in the SCM, you can see they have different things in there. So let me pick up only the structural equation modeling. Right. Now, here you can actually specify your model very easily. Okay. So all that you need to understand is the syntax of this. Okay. It's not a complicated one. So the moment you have done your conformatory factor analysis, this becomes much easier to write. In fact, you can copy and paste the syntax from the conformatory factor analysis and paste it here, and then do the customization of your modeling structural model. Okay, let me now tell you how to do this. Okay, so we have this interface where I clicked on SEM, and there we got this model, right? Now, in the confirmatory factor analysis, when we did this specification, we also had an output called the Lavan syntax. If you recall, I did this one Lavan syntax yesterday. So that gave us these details, correct? So I can, if I want, I can copy this. Like if you're not interested into typing, then you can make use of this. So just copy this. And go to the structural equation modeling section. And here, I think you can paste it out. Let me see, how do we do that? I copied it. And or else copy to the clipboard. Okay, sure, we can do this. Why it's not doing it? Okay, I think there's some issue with me, my thing, or I'm forgetting something. Okay, never mind. What you can do is, see, you already know the factor structure coming from here, right? So you know that information integrity, interface utility, and security. Now, all these are having their own indicators. So the first thing what we need to do in a structural model is to specify these things, so that we have a setup all clear for the structural model. Okay, so now these are the ones which are there. So let me do one thing. In the structural equation modeling, you can just type it out. So just notice what I'm going to do. So information integrity. Now I said that these have my indicators. So put a equal to sign and then the tilde sign. Okay. And then you write Q7 plus Q8 plus Q9 plus Q10. Okay. It is as simple as that. So name of the construct, I'm just made it short for writing purpose. So information integrity equal to this, and then security. I can again short it. Security is equal to, now my indicators were for security Q1, Q2, and Q3, right? So Q1 plus Q2 plus Q3. Okay. Similarly, for utility, I'm writing utility equal to tilde sign. Now, where you get the tilde sign? It is just below your escape key. You will get the tilde sign there. In your keyboard, just below the escape key, you get the tilde sign. Okay. And then you have Q4 plus Q5 and Q6. Right. So now this is my CFA model which I have put up here. Right. Now I want to establish my hypothesis testing. Right. So one thing which I get from my research paper, if I follow the model, I want to see that how utility gets affected by security and integrity. That means I can first see what is the relationship between this hypothesis H2 and H3, right? So I can do that. So how do I write H2 and H3? That is your information, so interface utility, it becomes your dependent variable, and information integrity and security become your independent variables, right? So that's what we are going to specify here. So utility becomes my dependent construct. Now notice here that when we are placing up a structural model, we are putting a tilde sign only. We are not putting a equal to sign. And then which are the ones which you want to specify as independent? So the information integrity and security. So that's it. So you're all set with this one structural model which you have specified here. If you want, now if you want to specify for your hypothesis H1, that is information integrity is your dependent variable and information security is your independent variable, then you can just place another. So at the same time, you can just test this out. II becomes your dependent construct and security becomes your independent construct. So this is a typical syntax in Lavaan package. So wherein the dependent variable followed by a tilde sign and independent variables separated by plus are specified like this. Okay. So are you clear up till here? Any queries? So any questions at this stage? Is the specification clear? Hello. Hello. Are you able to hear me?
Yes, sir, we can hear you.
Okay. Is the specification clear?
Yes.
Okay.
Clear, sir.
Yeah. So so the idea is very clear that first thing what you need to do is specify your constructs with their respective indicators. So I've done that. So the first three statements here, you can see it is just that. So it is as good as writing an equation, right? Now, and second one is to specify your structural model based on your hypothesis. So you can see that utility is the dependent construct and information integrity and security are independent constructs. And then, so these were referring to hypothesis H2 and H3 as you saw in the model. and then information integrity being affected by security. So all this you are writing just like a sequence of code. Okay, so very easy to write, right? So this is nothing like no rocket science here, because it's just a specification of your model, and first you are specifying the construct and then you are specifying your hypothesis, right? So here once you have done that, again in a Windows system you can press Control and Enter. Since I'm in Mac, I've used Command and Enter. Okay, so you can just put Control and Enter. Right. So the moment you say this, you see it's saying model applied. So automatically on the right hand side, you get all the structural specifications. Okay. See, it shows you all the details of a structural model. Okay. Are you able to get this? Yes. So you see this is the regression coefficients which you are getting here. So this is exactly what we want to look at as far as the results of the which has to be reported in the paper, regression coefficients. See, just you have to specify the model and then you press Control Enter, and automatically on the right hand side you will get the complete structural model. Right. I hope you are able to follow this. If you have any difficulty or any queries, please ask me. Okay. Yeah. So now you see this. This is what we are interested in finally, right? When you are testing for the hypothesis. Okay. So let me add up some things which will give more, what I say, more information about writing some discussion around it. Right. So let's say in our output options, I can have some, if you want to report some additional fit measures, you can. So you can pick up this, you can pick up a R square. Okay, and then you can pick up standardized estimates, right? And then you can show the path diagram. Right. So all the structural, and so you can pick up this additional fit measures, R square, standardized estimates, path diagram, show parameter estimate, show limit. So all these things are available. Okay. And you see the typical structural model also is ready with your details. Right. Of course, you can use this structural model. Okay. Now, how do we interpret these things? So let's look at the table called regression coefficients, because that is our interest when we want to test our hypothesis. Okay, so when we are testing this, let's look at you can see here it is given predictor and outcome. So predictor is an independent variable and outcome is a dependent variable. Or this is predictor means again independent construct and outcome means dependent construct. So now the security and integrity, information integrity. Security and information integrity, that was what? Security and information integrity. So I am testing that for H1. That is my H1, right? The first one is a H1 hypothesis. Now, how do we understand this table? Again, you see, they give you unstandardized estimate, then you have standard error and Z value, and then the P value. Of course, you see the P value is very small. It is e to the power -7. That means the first non-zero value after decimal is at the 11th place, right? So it is a very small value. So it's as good as its indicator that security is influencing information integrity. Okay, so P value very close to 0 means the hypothesis is tested significant. Okay, or there is a significant relationship. Now, what we should be interested other than the P value is also the standardized estimates which are associated with it. So you can see that your standardized estimates are given here. Now, how will you make use of the standardized estimates? Usually the standardized estimate is very good for storytelling. Okay, that means you can describe more than only suggesting that whether it's a significant relationship or insignificant relationship. You can add more masala, I can say, to your discussion in your research paper. Okay. I'll tell you how. Now, just have a look at the other two relationships where the utility is the dependent construct and the information integrity and security is your independent constructs for that model. Now, if you consider this regression, here both of them, again, I see that they are very significant and the sign is positive. So estimate indicates itself that it's a positive relationship. However, now comes the role of standardized estimate, which will tell you that among these two constructs, information integrity and security, which has more influence on utility. And that is where we make use of this standardized estimates. So the standardized estimates give you that relative importance of the independent constructs over the dependent construct. Okay, so I can clearly see here from the standardized estimate that the influence of information integrity is more on utility rather than security. Now, this is an interesting finding, and if you want, you can even write on this about why something of this phenomena is observed in this study. Like, for instance, the story what I'm going to tell here is that people are more concerned about integrity of the information rather than security mechanisms, right? And which is generally the right thing or right phenomenon which we generally observe in internet banking because people are more concerned about whether the information is fiddled with rather than whatever security mechanism is based on. So they don't, really speaking, the users do not care for really speaking, the people do not care for the security mechanism much, but they are more concerned about their integrity of the information being maintained, right? So this is something which we can write and which is coming through our research as well, right? So that's how you can make use of this standardized estimate for giving some nice story for the discussion, because generally we have a discussion page after the results, because where we actually discuss our results, right? So instead of just having a plain vanilla structure that, okay, we found this to be significant, we found this not to be significant, which is just a very bland way of presenting your result. So this adds some kind of a flavor to the discussion, because this gives you something to compare, right? So whenever if you have multiple constructs affecting a single construct as a model, then there you have a rich discussion coming up about the relative importance of one construct over the other, right? So that's where I see there is a lot of value addition in terms of this standardized estimates. Yeah. So any questions at this stage? Any questions? Anything which, any thoughts, if you have, you can share, and we can discuss on that.
Sir,
Yes.
sir, suppose I am working with two independent variable and one dependent variable. So, is there any cross-loading, the possibility of cross-loading? Then how can I measure the significant cross-loading of two independent variable on a one dependent variable, sir?
No, cross-loading happens at the early stage. Like you see, when we are, one minute. So, like if I'm understanding it right, that you already have you done, if you do a conformity factor analysis, there you, if you have got the validity set up, then I don't see that as a problem coming up in structural equation modeling. That means what I'm trying to say is that your conformity factor analysis should be done before you even do for structural analysis. Otherwise, it will create a lot of bugs in your structural model. So you cannot just directly go to structural model assuming certain indicators would be applicable for your construct, right? So your chance of cross-loading will never happen if you have followed the conformity factor analysis procedure, right? So, and of course, those details will not get, if there is a cross-loading, you have to remove that at the earlier stage itself, rather than like looking for some remedy at the structural analysis stage. So that's why we see we actually have two stages where we can remove the potential cross-loading, right? So one is at the exploratory stage itself, you can do using principal component analysis. Like when you look at here, and if you have no cross loadings, then only you proceed with a CFA, right? So see, the all problematic things you have to remove it at the early stage itself, and you cannot keep it at a final stage, because structural analysis comes at a final stage of your structural equation modeling. So confirmatory factor analysis is another stage where you can check that up by having a rigorous validity procedures, which I discussed yesterday, like average variance extracted should be greater than the square of the correlation between the constructs. So in that way, we establish a discriminant validity. So once you have established discriminant validity, then there's no question of cross-loading, right? So so that's where we need to do, because all these are very preparatory stages where finally you are ensuring that your results in structural model are robust in nature. So did I answer your question, or did you have something else in your mind?
Okay, thank you, sir.
Okay. Any other questions before we proceed? Okay. Now, so this is how you specify your structural model, and also then you bring in your output coming from regression coefficients. So that is what we are interested. We may not be interested in looking at gain factor loadings, because that is something which we have already done in the CFA, right? So when we are testing from the hypothesis point of view, this is the only table which possibly would be of interest. Yeah, the other one which I just used, it called R square, right? So generally there is one pertinent question which comes up, that can there be R square even in a structural model? Like in linear regression, we do that, right? So is there a possibility of a R square? So you see this R square, I have checked it out. So let's look at the R square table. So now you see that this is in R square, like in confirmatory factor analysis, we do not have the construct level R square. But here you can see that they have given you a R square with some construct. So what does this mean exactly? Right. So like information integrity, you can understand that information integrity was a dependent construct and security was an independent construct. So what it means is you can think of this as a regression equation, and the R square of that equation is given out here. Like for instance, information integrity being a dependent construct and security being a independent construct, the R square of that particular equation is 31.71%. So what it means is that the security has an explanation of 31.7% of the changes in information integrity, right? Similarly, if you look at the utility, which is corresponding to that R square, has been written as 0.548. So what it means is it is referring to this regression model where I've specified utility as my dependent construct and information integrity and security as my independent constructs, right? So that's where this regression R square refers to the model fit of this particular regression equation. Okay, so it is possible to have a R square for each of our structural models or structural equations. Okay, So this is where we can quote this. Like I can always quote that what is my R square for my this model and the other one. So these are there available and you can directly quote it and you can suggest that how good is your model in terms of R square. Okay. All right. So this is about the R square part. And of course, if the other thing which we generally place is the path diagram. The path diagram is just a visual depiction of your structural model, right? So that it actually specifies the same thing. The only thing which it specifies here is the standardized estimates in this. So you can see 0.74 of information integrity to utility. So you can see it is as where is it? Yeah. Oh, sorry, it shows the unstandardized estimates. So 0.74, but you can even, if you want to, this to be displayed within this, I think we can do that, not here. But yeah, certainly this here it's showing you the unstandardized estimate or between the relationship. But never mind. So the idea is that it just gives you a visual depiction of the structural model, okay, with the different weights and other things. Right. And of course, if you do not want the legend to be shown, it can be removed and you can just draw the structural model. Right. Now, if I have to just do the same thing in my other package, which I told you, I can do that. So let me show you in the web-based version, which yesterday I showed you. So, and those, so tiny. So I'll also, I think, post it in the chat box. tinyurl.com sem-kb. So tinyurl.com sem-kb. In fact, whatever I did it in JAS, exactly it is the same idea which I'll be following here also. The only thing is that here it has been already tailor-made and like you can exactly put up whatever content you want it to be put up in the research paper. So you can see here that I've specified in the same lines how the model has to be specified and so on. Okay. Okay, I might have to add one more thing. So I just have to write that integrity of course you can use this for any other data set also. Yeah. So you can see all the things required is directly given out here. The moment I type there, all the changes happen automatically. Right. Yeah. So now this is the one along with this. Yeah. Yes. So this is about your structural model. In fact, you have got everything in the same way how you would have got there. But yeah. So these are the variables. So dependent variable is given here, independent variable is given here. This is the output which you might report. So you can just copy paste it and you can report it along with these systems. Right? Exactly the same what you have got in JISU. Right? So we in the regression coefficient table, we got that. So this is basically in a nutshell about structural model per se. Now, sometimes it is optional because many journals do not ask for again a model fit indices of a structural model. But even if you want to have, that can be provided as a model fit index for structural model as well. But typically, in any what I've seen is that in any standard research paper on structural equation modeling, they do not generally require to quote the model fit indices for structural model. For measurement model, it is okay, but for structural model, it is not required. But in case it is required, that also is available in this particular software. Right. So this is about structural model. Of course. Now let me come to the another variant or another topic related to structural model, what we call as alternate models. Okay. Now, what is the use of this alternate model? Now, alternate model is a very effective way of assessing which structural models are the best, right? Okay. So now let's say here I have specified this particular relationship, right? So this was one of the structural models which I have got here. But let's say I'm interested in finding out different structural models and find out which is the best structural model which I can think about, right? So, and then find out a comparison between the different tools. That's why we call them as alternate models. So if you look at here, when I said in structural equation modeling, this is model 1, right? But suppose I want to add another model. In model 1, I have got this, right? In model 2, suppose, I hope I am able to copy this. I think some other way to copy. Okay, lucky. So Command C and Command V is working for it. Okay. So you see this one here. Suppose these are all same, but I want to change something. Say I make a different model. It may not make sense logically, but let's say I just go with utility only dependent on information integrity, and information integrity only dependent on security, right? Now, if I go with this model, you can see model 1, I didn't have, I had security there, but here, okay, sorry. I'm removing the security and then also trying out some other model. So I'm going to make like a chain model here and say command enter. So now you see how my model looks like, right? My model 1 was this, but model 2 is this. So this is my alternate model. So I'm making a chain model here. As you see here, it's a chain model. Security, integrity to utility. Okay. Now I want to check whether my chain model is great or whether my earlier model is great. So I have model 1 and this is model 2. Now how do I test which model is good for me? Okay. Now, of course, this is where we may require to understand the goodness of fit measures, right? And that's where the utility of the measures will turn out. So what you can, okay. So now have a look here. We have here model 1 and model 2. Okay. Now here you see there are a lot of different statistics which are given out in order to suggest which model can be better. Does my model 2 fit better or model 1 fit better? Okay. Now, interestingly, all the tests are also done here, so you don't have to do any additional thing. Okay. As you can see here, that from the AIC and BIC, now you see there is something called AIC and BIC. So AIC, I think it stands for Archaic Information Criterion, and BIC, I don't recall the full form, but both of these are like a indicator of badness of fit in sense. That means lesser the value, better it is. So as I see here that when I compare my model 1 and model 2, it seems as if my first model seems to be appropriate, consider more or better than the second model. Okay. So you see this is the difference which you get. So these values are higher in case of model 2 and the values are lower in case of model 1. So suggesting that model 1 is a better model compared to model 2. Okay. Same way, if you are looking at the fit measures, there also you can have a comparison, and you can see that my model 1 has better values for my CFI and all those things which we discussed yesterday. So compared to my model 2. Okay. Now this is another study which you can carry out if you are interested in suggesting which model might better fit or better explain the things. So that's where this alternate model concept can be utilized. Okay. So you see all these things can be done very easily. Now, in fact, alternate model concept itself is something where we can test whether a mediating relationship is great. Like that's what I am going to discuss even in detail in the next session. But however, here I'm just trying to make up a base for what we understand by alternate model. Now, why do we do an alternate model? Because we want to see whether the alternatives which we have for developing our structural model, are they equally good, or any particular model is better than the other. Right. Now, here we can clearly see that model 1 was better than the model 2. But let's say in some cases there might be equivalent models. That means you cannot really say that one is better than the other. So how do we test that as well? So that's where we check with this test called the difference test. So you see here there is a difference test which has been already carried out for these two models. Basically, what is this difference test? This test is nothing but the difference of your chi-square. So you can see the difference of the chi-square, 52.99126 minus 45.137, that it gives you 7.85. Okay, and then the degrees of freedom. Now, based on this, you are doing a test here, testing whether the two models are equivalent or not. And here, the moment you see that the p-value is very close to 0, it means that there is a significant difference between the two models. So I can say that the two models which I have developed here, they are not equivalent. All right. So that is another thing which you can do with structural models, wherein you can have different structural models and then try to see which model has a better fit in the context. So here I can clearly see that my chain model is not being very effective. Rather, this is what I would say the relationship on all the three sides, that seems to be a better relationship, where security is influencing information integrity, and then information integrity is influencing utility, right? So this is how you can see the relevance of different structural models, and then according to that, you can write your discussion in your research paper. Right? So let me even give you one more model so that we can have some different perspectives. So this is one chain model I run in model 2, and this was all set from either ways. Let's say I try to do it the other way around. In sense, I change the role of information integrity. So let me just copy the details. So Command C, Control V can do that. So what I'm going to do is I'll just change, I'll do a role reversal. I'll just keep it this way, but only thing is here I'll just change a role reversal. What I'll do is I'll just keep security getting affected by information integrity. Of course, it doesn't make sense, but I'm keeping it for having a different model altogether. So Command. So now we have three models in place, right? So now I've just changed the role, but do I see any differences in my now what happens here is in my model 1 and model 3, they are almost the same. I just change the role, so that's the reason it's not able to find out anything out of that. So I can say that the model 1 and model 3 structurally they might sound same, but then logically it may not make any much of a difference. In fact, you can see here that the fit wise they are same, the model 1 and model 3, right? So fitting with the data, there is no problem. From the data point of view, there is no problem between model 1 and model 3. But from the logic point of view, there is a problem, because that purely depends upon your theory, right? Because the theory will make that directed relationship. So my point here to do the third model was to suggest that even though sometimes that could be a fitment with the data, but logically it may not make sense. So you can see that model 1 and model 3, they are almost they are quite equivalent, right? You don't have any difference though, right? But the only thing what made the difference in the model 1 and model 3 was the interchange of the roles. Now, something which doesn't affect the model fit per se, but it doesn't sound logical when you are looking from the theory point of view. Okay, so that's where the there is some restriction on the alternate model concept. So you might try changing the structure and then test it, then of course it can give you some understanding about the model fit. But if you are just swapping, keeping the overall structure the same, then alternate model will not be able to help you out with that structure, like whether it is a fit structure or not, because it will accept both sides as equivalent, right? So that's why I deliberately did this particular thing, so that you understand that if you make any structural changes in the model specification, then only you can be able to test which is a better model fit with the data, right? Otherwise, if you're just swapping some things, keeping the overall structure the same, you may not be able to figure out, because it's because softwares do not understand the logic, and that is only pertained with the researcher who assumes a certain direction. Okay. Yeah, so this is alternate model from my side on structural equation modeling. So this alternate model can help us in one way when you are actually changing the different, trying out different structures and just checking out the fitment. When there is, so in those cases when there is no theory background and you want to develop some new theory, then alternate models can be thought of as an option. Okay, so that's where the role of alternate model comes into place. Right, now there is another way of looking at which can be a better model fit, and that's what comes from what we call as the modification indices. So yesterday also, and I think in this also you have a option of modification indices. So you can see I not checked the modification indices. Suppose I check the modification indices. Okay, and then there is something called hide low indices. Now, what is this modification indices? Now, modification indices is basically a way to manipulate your structural model, or even for that matter, your confirmatory factor analysis model. So sometimes what happens is, if you do not do a very good job at the exploratory level, there might be possibility that you would have invited some cross loadings, and that can get also reflected in your modification indices. Okay, so let me explain you in a way. Say let's look at the modification indices. Now you see, in the modification indices, it gives separately for each of the models. Okay. Now let's see the very badly shaped one was model 2, right? So let's have a look at model 2. So in model 2, okay, what happened? Achha, there was no small value. So okay, so I unchecked the hide low indices. Yes. Now
Sir, I have a question.
yes.
What appears from this model actually? I believe this is a first order model. But if I want to go ahead with the second order model to see further course of relationship between the variables, how we should do that through this software? I mean through JISU.
Okay. From my personal viewpoint, I never believed in higher order models because higher order models is like you are deliberately forcing some things because first of all, there is always a issue of validity with higher order models. Anyway, notwithstanding that, my personal opinion, the higher order models can be done here by okay, let me just take this way. You can specify your higher order model very simply with this. Like suppose I say here in my, okay, let me take up the next model. I'll just show you with a, so say model 4. Again, I might copy. Just a minute. Let me just copy a content. Control. Now, suppose I say that utility is not Q4, Q5, Q6, but so you can specify as simply as this. So you see, I put equal to sign and this tilde sign. So this is not a structural model. This would become a higher second order factor where utility is a second order factor. Not second order. Yeah, second order factor, and II and security are the first order factors. So command enter. Okay, it's giving me error because, okay, 1 minute, because I have checked this out. So let me uncheck that. So you can see this model 4, how it looks. So this is your actually a higher order model.
Sir, in AMOS, actually, we have a constraint that, for a second order model, we need a larger sample size. I mean, if we are starting with 300 sample, then to go for, for a second order and then to third order, we need a bigger sample size, more than 1,000. Here, is it required?
No, see, the point is that for every the rule of thumb for any factor analysis is that there should be for, see, it depends upon how many questions you have. So if you have, say, for each question, the rule of thumb is that you should have 10 samples, right? So suppose you have 10 questions, like here, for example, here, if I have 10 questions, I have to have at least the sample should be ranging from, for each question, you should get at least some 5 responses or 5 to 10 responses. So roughly you can say 10 into 10. Yeah. So at least I need 100 responses for my 10 questions. If I say that there should be 10 people for each question, right? So you see that becomes your sample size of 100 for this. So with a sample size of 100 and with these 10 questions, I can have a good factor structure coming up, or a stable factor structure coming up. So it is a matter of getting a stable factor structure. So if you have too many questions, then of course you require more sample size to get your stability in your factor structure. And that's why it is suggested that if you're, again, you're talking about higher order factor, right? So in a higher order factor, it depends upon, suppose you have, like here, I have only one higher order factor, and these are there. So altogether, again, it boils down to, now I have only used 7 variables here, right? So the 7 variables are there. That means I might be able to do it with 70 as a sample size effectively, right? So 70 would be the sample size for this particular model.
Sir, how do I know which model is more accurate and which model we should go for?
That's what I'm saying. That's what I discussed with your model. This, right? Alternate
Accuracy
model
and validation of the model means which one is more accurate, and how do I check the validity and reliability of the model?
That's what I'm saying. If when it comes to higher order factor, like, are you talking about higher order factor or your general this? My question is that are you speaking with reference to a higher order factor, or are you talking about
I'm speaking with I'm speaking with regard to the higher order factor. Suppose if I've taken a questionnaire with 40 factors and I got two models based on the construct. So how do I check the reliability and validity of the model?
Okay, the first thing what you always have to do is first check the reliability and validity of the first order factors. Okay, so that is the first thing which you need to do, which is generally the case. Even if you are going for higher order factor analysis, the first thing what you need to do is find out the reliability and validity of the first order factors itself, right? The immediate factor structures. Like here, in this example, I had 3 factors, right? So I have to find out the validity and reliability of these 3 factors, which I did yesterday in this session, right? Once that is established, then see, higher order factors are usually a notional thing. It is not something where, so when I say notional means that it is coming from the theory. Okay, it's more about face validity rather than having convergent or discriminant validity. Okay, because you have already established convergent and discriminant validity at the first order, right? And this is where I always had a contention. And I never believed in higher order factors because of the same reason. Because see, the moment you are saying that I'm establishing the convergent and discriminant validity at the first order level, how can I expect them to again converge in a higher order factor, right? something is a food for thought, right? You are already extracted the common variance and at the first order level. And how are you like considering that something should converge at the higher order? So then what it basically means is it's just a notional thing which you have decided upon, right? Like, for instance, if I say service quality, let's understand one construct called service quality. Now, service quality, like Parshuraman suggests that he has six, no, I think conventionally five. Yeah, so five, if I consider service quality as the second order factor, and the other things were tangibility, then reliability. So I think that there are some five, I don't recall. Surfall model, it has five dimensions. So now that five dimensions they said, and they say that it is for service quality. Who says so? Because he notionally suggested that it could be a indicators of service quality. But the moment I say that the tangibility is different from say reliability of a service, that itself I made that, and now then you say that they again converge to a higher order factor called service quality. Really speaking, it doesn't make sense from the statistics point of view. So it is just a notional point of view. Like, okay, you say that tangibility and reliability of a service, they are part of service quality, right? So what I'm trying to make out is there's nothing called convergent and discriminant validity for higher order factors. You can always have convergent and discriminant validity for the first order factor only. I hope I made that clarification about
Yes,
your thoughts.
yes, because for my research, I need to clarify these things, because if I'm going for a model, and how do I check the validity and the reliability of
Yeah,
it?
so always remember this, that or rather, this is my suggestion. If it's for your PhD thesis, then
Yes, PhD thesis.
okay. So if it's for PhD thesis, never think about higher order factors, because that is something which is people are just writing for the heck of writing. That's what I feel, because it is mostly about forcing something to come and convert, because always from the journal point of view, people demand some new perspectives. When you're saying Bima, okay, usko laga do ek saath. So what does it mean? Like, it simply you're forcing people, some ideas to converge to something for which you already those ideas have been validated at the first level to be discriminant and other things, right? So then you're forcing it. So it is a very notional thing which I see from, like, okay, notionally I can say that these might turn out to measure this. Okay, but the moment you say that they already have been established as discriminant validity, actually speaking, there's no converging idea coming further. Right. So that's the reason I said that I never believe in higher order factors, and especially for PhD thesis, this is my genuine advice. Never go for higher order factors. You do the test at the first order level, and then once you're through with your PhD thesis and you have to just develop more papers on this, then probably you can go for higher order factor.
Okay, thank you, sir. Thank you.
Yeah. Right. So, like, it's actually, for me, it is always sounds very funny about having something called higher order factor. Okay, but yeah, no, technically, to specify that model, I just showed you here that this is how the higher order factor will look like. Like, if I say security has these indicators, this becomes your first order factor, and this utility, if I specify as reflected in security and integrity, then this is how it would look like. And now answering another question, that which model is better, that you can always check out from your model fit indices, right? So this is where we come from. Where is it? Yeah, so now you see we have now got model 4, model 1. Yeah, so now we can clearly see there is a big difference. No, okay. Interestingly, some again, yeah. Now, if I am trying to compare whether my model 4 is better or model 1 is better, right? So now I'm getting an answer that, of course, my model 1 is still better than my higher order model, right? Because my error wise it is less, and even if I look at my chi-square degree of freedom, okay, now in chi-square degree of freedom, it sounds as if there is a little bit of contention. So again, ultimately, if you look at this, now here it is suggesting with chi-square difference test, it is suggesting that again there is not much of a difference between model 1 and model 4. So maybe if I want to publish another paper using this, that model 4 is a higher order model. The utility consists of security and integrity, and then I can write some the paper. I can justify it by saying something. Okay, but seriously speaking, unless you have a conviction in that higher order model factor, I would not suggest you to go with that, because it's always notional. There is nothing called convergent or discriminant validity in these cases, right? But here I'm getting actually an idea that my model 4 can be even a good alternative model. Like as far as fit is concerned, it's not. In fact, I'm getting a much better thing here. So maybe I might think of this in the future. Right. All right. So this is about like comparison. Yeah. So I was talking about this model fit in modification indices. So let me see. I can just get rid of this model 4 for some time. Yeah. So in the modification indices, now this modification indices again is a strict no for all the PhD students, but of course certainly for researchers this is like a way to do some manipulation. Okay, so like here you can see that there are cases where it is suggesting that some score of modification index. So what does this mean exactly? It says that if you club Q9 and Q6 together, you will get a better model fit. So modification indices are basically those ones which indicate that if you work on that particular relationship as specified by these model modification indices, then you will get a better model fit. Okay. So here it is suggesting, say for the model 2, because in model 2 I had a problem. So I was looking at that model 2. So it is suggesting that I should have a relationship between security and utility. Then my model fit will be better. And that's why you see it is been put in a higher priority. Okay. Usually, modification index, if it's greater than 4, then you might consider this relationship to be put in. So if you see in my model 2, let me just go to the model 2, which has specified. So now here in the model 2, I have not specified any relationship between utility and security, right? So that's why it is pointing out that if you make that changes, right? So you can see here, I'm in model 2. If this security and utility, if I use that relationship in my model, then I'll have a better fit. That's what we're trying to say. So let's suppose I go with that idea. Like this is how you can manipulate your model. Okay, that's why I said this is a strict no for those. So security and utility. So it's suggesting either you can have a covariance model or a relationship, directed relationship, or a bidirectional relationship. So suppose I go with a bidirectional relationship, okay, and then put utility. Now first understand that right now my, where is it? Let's look at, yeah. Right now between model 1 and model 3, I have a stark difference, right? In fact, model 1 and model 2, there is a stark difference in this, right? So now, because of this modification which I have used from the modification index, yeah, so you can see here 0.04 and here 0.049. So model 2 is bad here, right? And goodness of it also you can see 0.9979 and here it's 0.9975. Okay, slightly bad. Okay. So if I include this now as suggested by modification indices and say command enter, so just notice the change what happens there. So now you see my model 1 and model 2 have become almost equal, right? In fact, it has become equal now. So you see, if I miss out on something and the modification index will pull out that, okay, this is the relationship you didn't consider in my model specification, right? And that's why your model fit was bad. But so if you consider that, my model fit will turn out to be good. Okay, so you can see that how you can use modification index for better fitting the model. So it sometimes some things might be logical, sometimes it might be completely illogical. Like for instance, if I had not done this change, suppose I'll go back and undo this change. Okay, so when you undo the change and then do this modification indices again, you see it's saying you make a relationship between Q9 and Q6, but Q9 and Q6, they are indicators of two different constructs. Now this is, of course, it is it's saying that if you do that, your model fit will be better, but strictly speaking, I can't do this, right? Because it doesn't make sense that I'm suggesting there is a relationship between a indicator of one construct and another indicator of another construct. So that doesn't make sense. So I cannot utilize this. Even technically, I might get a better fit, but logically, it doesn't make sense, right? So you see, you might make use of modification indices if it helps you better your model and it is logically also sound. Then only you can make use of modification index. Otherwise, it is a strict manipulation practice to maybe to fool the journal or to fool whoever you want to, like, to get it published. Okay, but that's why I said this is a strictly unethical practice if you so, and though might there might be some people who might use it for getting some idea about what could be the possible relationships, but you should not force it uh, on any model to get it published, right? So, and especially this is a strict no for PhD scholars who are trying first level analysis. So I don't want you to get into manipulation activity with your thesis, right? So, but I just wanted to discuss this because there is a tool through which we can better our model specification, right? So this is what our modification index is all about. Right. I'm done from my side for this session. So if you have any questions, I can answer that. Otherwise, we can discuss for lunch and come back for the next session. Yes, anybody has any questions, I can address that. Hello. Yeah, so if you have any questions, we can go ahead with that. Otherwise, we can discuss for lunch. That's why.
Audience, you have any question? Anyway, so we have come to the end of the first session of day 4, and the session has been conducted fruitfully by our resource person, Dr. Kartikeya Bola sir. We are highly indebted to him to explain us the nuances of structural equation modeling, and how we can do it in a very simple way. He has explained all the difficult steps in a very conducive and very effective way. So we are looking forward for the post-lunch session where we are going to learn about mediation and moderation, and that would be a very interesting session for all of us. And before we take a break for lunch, may I request all the participants to open their camera for a group photograph. Participants, can you please open your camera? Great. Thank you so much.
Thank you very much, and I'm looking forward to the next session.
Yes, sir. Thank you so much, sir, once again. We would join dear participants sharp at 2 o'clock, and we will rejoin at 2 o'clock. Thank you, sir.
Yeah, thank you.
Thank you. Good afternoon, sir. We are waiting for the participants to join.
Sure, sir.
So, sir, let us start the session. It's 2 o'clock.
Okay.
Yeah, let me start the session. So, good afternoon, dear participants. Welcome you to the 4th day, second session of the 5-day national workshop on research methodology. And in the second session of the 4th day, we are going to have a lively session on mediation and moderation analysis. And once again, warm welcome to Professor Dr. Kartikeya Bholar sir. And I hand over the session to you once again.
Okay. Yes. Thank you.
Thank you, sir.
Yeah. Okay. Let me share my screen. can see my screen, right?
Yes, sir.
Okay. Let me just. Right. So the topic here is about moderating and mediating variables and how they are utilized in research or in research models particularly. Let me just expand this. Right. Okay. So now typically these are some research. Usually what happens, structural equation modeling. We generally, if we are looking at a very basic structural equation modeling, we are okay. Yeah, let me just begin once again. So when we are talking about structural equation modeling, we had talked about conformatory factor analysis and then the structural analysis which we carried out today in the morning session, right? Now, these are like basic things which we have to do in structural equation modeling. But sometimes from the journal point of view, as well as from the interesting research point of view, we would like to consider some variables or other, if it is in context of structural equation modeling, we consider some constructs to be either moderators or mediators, right? Now, because otherwise what happens, things become very routine-ish when it comes to a research in structural equation modeling. So to make things interesting, some constructs are usually considered as moderators or mediators. Now, but most often, and this is a very fundamental question, I think, which was also posted up in the previous session, is when do you consider something as a moderator and something as a mediator? Now, adding to that same confusion, I'm also including one more variable which might also get confused with moderators and mediators, is the control variables, right? So, like, of course, the control variables was not part of this session, but I thought it would make more sense if I explain in totality about moderators, mediators, and control variables. Now, as such, the concept of moderation or mediation or control is not restricted to only structural equation modeling. So, for that reason, you may use moderators, mediators, or control variables with any other techniques as well. Like, for instance, say linear regression, I can make use of moderators, mediators, and control variables, right? So, so I'm just trying to clarify that people might have a notion that this is part of structural equation modeling. No, it is not. It is just that you can do in structural equation modeling moderators and or use of moderators and mediators, but it's not necessarily going to be restricted to only structural equation modeling. Okay. Right. So with this basic background, let me first give you an overview about what is a moderator, what is a mediator, and what is a control variable. Then we will see in structural equation modeling how to do a moderation analysis or a mediation analysis, right? So that's where we will be heading to. Right. Moving ahead, let me bring it. Yeah. to the first concept of what is a moderating variable. Now, I'm just taking one snapshot from the classical research paper. So I have given the reference out here from Barron and Kenny, 1986. This is again a most sought out paper to find out the distinction between moderator and mediator. Okay, so and it has been quite well explained in this paper, the differences. So I'm just trying to discuss the same things which are discussed in this paper, and with some add-on value if I can do with this explanation. Now, what is a moderating variable? As it is defined there, it suggests that a moderator is a qualitative or a quantitative variable that can affect the direction or strength of the relation between an independent or predictor variable and a dependent or criterion variable. Okay, so now we have a bit of confusion about what is the difference between of course, we always have an clear idea about independent variable and a dependent variable. So where does this moderator come in? Right. So here the moderator is something which will work as a catalyst. That's why I use this term catalyst. Catalyst is something where is something which will affect the relationship of a independent variable and a dependent variable. So usually we have two ways which a moderator can affect the relationship between a independent variable and a dependent variable. Now there are different nomenclatures for independent and dependent variable. So a independent variable can also be called as a predictor variable, whereas a dependent variable can also be called as the outcome variable or a criterion variable. So in different literatures, the people use these different terms, right? So I just want you to be familiarized with the terms and their equivalents. So predictor, independent variable, they all mean the same. And when it comes to outcome variable, dependent variable, criterion variable, they mean the same. Okay. Now, there are two ways it can affect the relationship. I think we'll discuss this part. One is the form of the relationship and the strength of the relationship. Okay. Again, I'm referring to another paper by Sharma et al. In 1981, where they have discussed particularly for how to identify and analyze moderator variables. Right? It's a classical paper again in Journal of Marketing Research. So now there they have clearly mentioned about that a moderator can affect the form of the relationship or the strength of the relationship. Now the question is, what is the form of the relationship? Now, form of the relationship means that there is a possibility that you can have a completely different equation, right? With respect to one of the aspects in moderation. I'll just give you an example, something like this. For instance, if I talk about, say, the salary of a person depends upon, say, the experience, okay, and say qualification. Okay. So in general, I'm just talking about an example where salary of a person depends upon the experience of the person in that field and say the qualification. So now you know that salary of the person becomes the dependent variable, right? And whereas experience of a person and the qualification of the person, they can become the independent variables. So this is in general for a equation for salary in terms of experience and
Recording in progress.
okay. So this would be in general in terms of experience and what we say the qualification. Now, if I bring in another variable called gender, okay, and I would like to see how this equation will matter for a male and for a female. Okay. Now, it might be possible that for a male, both experience and qualification matters. Okay. But maybe for a female, experience may not matter much, but only qualification matters. I hope you got the clarity that in general, I have an equation. So let me somewhere bring it on just a minute. So I'm just placing it here for your reference, and then I'll go back to the once we get here. So experience, I'm just saying that it depends upon salary, say, I'm sorry, I made a mistake. Salary depends upon experience and qualification, right? Now, this is a general equation. I'm just placing that. But let me bring now gender, which is a moderator. If I consider gender as my moderator here, okay, then now gender, I'm assuming there are only two categories in general. So say male and female, right? Now here when we are considering male, I may say that salary is dependent on experience as well as qualification. Whereas when it comes to female, I may say that salary only depends upon experience. Now notice this, that for female, salary is dependent only on experience, and for male, salary is dependent on experience and qualification. Now, so that means what? When I'm introducing gender in the relationship between experience, qualification, and salary, I'm getting completely two different equations for male and female, right? Now, this is a case where you can say that the moderator is affecting the form of the relationship. Okay, I hope now you got the meaning of form of the relationship. So that means exactly whatever is the equation is different, completely different for male and female, right? Now, if I'm talking, let's say like this, say that I again use gender as my moderator, okay, and then use salary for male. Again, it matters, but it may matter in this way. Say experience requires. I'm just giving some estimate. Say 2 times of for male, say it means 2 times of experience and plus qualification. Okay. Whereas for female, let's say both matter, but it might be just 3 times. So now I'm just equating. Three times of say experience and 2 times of qualification. Okay. Now here you can see that both the variables are there which are getting effect, which are influencing salary in both male and female, but the intensity is different, right? So the intensity of the relationship is different. So maybe for a male, this experience matters twice, whereas here it matters thrice. Okay. So that means I'm saying that for a female to be qualified for getting a salary, they have to get more experience, right? And qualification also can be a bigger qualification to get the same salary, right? So that's where we are saying that the intensity is getting affected by gender. So here, in this type of example, I can say that the moderator is affecting the intensity or the strength of the relationship. Okay. So I guess this gives you a good clarity about how the moderator can affect. It can either affect the form of the relationship by completely giving you a different equation altogether, okay, or the strength of the relationship where you are talking about the intensity of a particular variable, right? So this is how in the paper Sharma et al. They have justified that a moderator can play a role. Okay, so right, so form of the relationship and strength of the relationship. Now when it comes to moderator being categorical, like what we just now explained, let's say gender was a categorical variable, it becomes much easier to distinguish the whether it affects the form of the relationship or strength of the relationship. However, when it comes to a moderator being a quantitative variable, things take a different turn. Okay. So there it becomes increasingly more confusing whether a moderator is independent variable or is it really a moderator, right? So that's where the problem lies when it comes to quantitative variables which are considered as moderators. Okay. So there is something called quasi moderator and something called as a pure moderator. Okay. How do we understand this quasi and pure moderator, and how do we differentiate what is a pure moderator and what is a quasi moderator? Okay. Now, let me again go back to the Excel sheet so that that things become more clear. Now, let me just start with some again. Maybe I can take up something. Say the same example with salary getting affected or influenced by experience and qualification. Okay, and perhaps something else which I can take. The experience is fine. I need. Okay, let's say age of a person, right? So let me use something like this: salary getting affected by experience and say age of the person. Okay, now if you look at here, experience and age, they are all both quantitative in sense that you are talking in experience of work experience, and age also is quantitative. Now let's say I want to use one of them as my moderate. Okay. Now, seemingly, when you use anything as a moderator, you have to actually go by theory that whether experience can be a moderator or age can be a moderator, right? So this has to be backed up by theory. Otherwise, sometimes things become very worse if I just go by my own understanding of moderator. So generally what we say is that suppose I go with a logic that salary depends upon the experience, but at the same time, age also might play a role in shaping up the salary. That means if I say that there is a certain salary for a experience of say 10 years, right? But if there is a aged person coming with 10 years, they might get more salary than a person who is a young person but has the same amount of experience, right? So in a way, what I can say is, though age is a quantitative variable, but I'm just conceiving it as something where I can clearly segregate the levels, right? Like I might say that somebody who has say age above 60, right, say 61, 62, 63, they may have a different salary with say 10 years of experience, and say a person who is a little younger, say 49, 48, 47, or so on, for instance, and with the same 10 years of experience, they might have a different salary, right? So there I might consider age as my moderator, right, on a relationship between salary and experience. Now, here things are not that clear compared to the previous example, because in the previous example we could clearly segregate and get the equations, right? Whereas here it becomes difficult for us to get a clear-cut distinction about a certain age. After certain age only the salary might increase or decrease, right? So that is where we have a problem in treating a quantitative variable as a moderator. So what do we do? So what is suggested is that let's have a interaction term associated with these quantitative variables. So we come across something like this. say I have experience and age, but clubbed with that is an interaction term where we say experience into age. Now, when we say this experience into age, we call this type of term as an interaction term, right? So I have something like this in a nutshell: salary and the interaction term. Now, it all looks fine, but there is one fundamental problem. Unless we say the equation doesn't really recognize which is a moderator, right? Because it is quite symmetric. So I can interchange and then say that my experience is my moderator and age is my independent variable, right? So how do I figure that out? So that is where we come across these two things called a quasi moderator. A quasi means false, and as the pure moderator. Okay, it's a quasi and a pure moderator. So when I have quasi and pure moderator in place, right? Now, how do I understand quasi and how do I understand pure? So when I run, I place this regression equation, right? Like salary as experience plus age plus interaction term. So if all the three are significant, suppose experience influences salary, age influences salary, even the interaction term which I got from experience into age, that also affects salary. Then under such circumstances, I can consider that age is a quasi moderator. Okay. Because unless you justify from theory, I actually cannot figure out whether experience is my moderator or age is my moderator, right? So that is the concept of a quasi moderation. But let's say when I place the same equation and I get experience to have a significant influence on salary, age does not have any significant influence on salary. However, the interaction term has a significant influence on salary. Then such a case, I can consider that age is a pure moderator because it has no role to play as an independent variable. It only appears in the interaction term. And that's why I can consider that as a pure moderator. Okay. So this is how I differentiate between a quasi moderator and a pure moderator. And these terms are only applicable when we have a quantitative variable where we are actually getting into a interaction term and so on. Right. Now, this is where this is the concept of moderation. So one is that, of course, moderation affects either the form of the relationship or the strength of the relationship. It can be a quasi moderator or it can be a pure moderator. Okay. Any questions at this stage?
Sir, could you repeat the steps once more?
Pardon?
The steps that you have shown for this particular calculation, the formula for the salary and this.
No, what I'm trying to say is this: when you are taking the relationship, you are introducing your age as, suppose, as a moderator. you actually have to place it as one of the independent variables and also put it along with the interaction term. So as I said here, right? So this is how you would introduce it as an independent variable as well as a term inside the interaction term. Okay. Now, obviously, if all the three are significant, when you place this regression model and put it across, if all the three are significant, yes, then you can only consider that age as a quasi moderator, because from the equation I may not be able to make out which is the moderator and which is the independent variable, because all the three are significant, right? But then if the age turns out to be insignificant and the experience and the interaction term becomes significant, then I can consider that as a pure moderator, because it is never appearing as a, or never getting into the role of a independent variable, but it is acting like a catalyst in the interaction term, right? So that's where you can consider that as a pure moderator.
Thank you, sir.
So,
Yes.
whether quasi-moderator could be treated as an equivalent to fuzzy logic?
Fuzzy logic? No, I don't think so. Fuzzy logic is a completely different field. I can't see any connection, remote connection also. Like, why do you say so?
Actually, maybe I have an abstract knowledge of it as well. Fuzzy logic, I thought that if 1 to 0 is the variable, then 1 to 0, anything could be the part of it. Just like if the quantitative moderator is their number, so somehow it could be affecting the model in the same way.
No, maybe I can say one thing though, that there are certain levels in the moderator. Okay, only after a certain level, you see that there will be a change in the equation.
Okay.
So that can happen. So most of the time, let's say, how I can understand moderator is that if we see there is some value addition coming up because of certain variable in an equation, right? In a regression equation, existing equation, that time you can consider that variable as a moderator, because that is affecting the strength of the relationship. Okay, so that's what I said here. Like maybe salary is dependent on experience. Okay, but then if I push age as my moderator, it is giving you more credibility. For instance, I'm just trying to give a logic about why I'm considering age as my moderator. Let's say think about a job where experience is crucial to be there. But then if there are two people with the same amount of experience in that field, but there is a person who is slightly aged, they may bring in some other experiences because of the age element, not because of their experience in that field, right? From some other surroundings, and that might add more to the work they might be doing, and that's why they should be paid more, right? So because of that reason, we say that age might become a moderator factor, because it is adding more to the existing equation. right? So that's how I can. So now there you can see that there can be distinct levels in the age itself, right? That means beyond a certain age, I only there is a value addition, but not at the very early stage, right? So that can also happen. Now, let me talk about some practical things. What generally happens? Uh, I'm sure some of you might have faced this also. At least I have faced this. Like, so when we are looking for our job prospects at different places, so sometimes we feel dejected because we think that okay, I had all the competencies, but still I am being not given the salary what I want, right? But at the same time, I see somebody who might be having the similar experience, but just because the person had some one was the age factor, and also about something else which was actually was not the part of this job description, but they had that experience, so that's why they were given more salary as well as right. So now that's where that value addition we generally don't think about, but that becomes a moderator. So that makes a difference. But suppose that person, the other person didn't have that, then they are as good as us. Right? So that's where things change, and that's why we call that type of variable as a catalyst, or which can be a game changer. That's what I can say. Right? So I hope I answered your question.
Yes, sir.
Maybe
Actually,
that
what I understood from your clarification that the fuzzy, it can't be a fuzzy because somehow the continuum could not create a level of change in the model. It would be changed only after a degree of certainty. So
right.
somehow that's why. Okay, thank you very much, sir.
Yes. So yeah. So this is about moderation in general. So let me just go back. So this is where I was telling about the interaction term. So this particular picture, you can see that predictor is actually an independent variable. Moderator is also will be considered as an independent variable. But then if predictor into moderator, this becomes your interaction term. It is affecting. But then suppose all the three lines, if all the A, B, C are significant, then my moderator would be a quasi-moderator. And if at all the path A and path C only are significant, then my moderator would be a pure moderator because it is only appearing in the interaction term in that case. Okay. So yeah, I missed out on this term called homologizer. The homologizer are the ones which I just talked earlier about with gender as a case. So homologizer is basically a qualitative moderator, right? We just said that earlier that it can be a qualitative or it could be quantitative. When it takes the shape of a quantitative, it usually is a moderator model like this, right? But when it is a qualitative, as I told you, it takes like for example gender, which I just explained. So that can affect the form of the relationship or the strength of the relationship, right? So now such type of like gender can be an example of a homologizer. Okay, homologizer is a qualitative moderator. Okay. So yeah, so details of this are actually there in this particular paper. So and it is I think freely it's also freely available on Google Scholar. I'm not sure whether I have kept this as a paper reference but anyway, you can. I'm sure you can get this in Google Scholar for free. Okay, so yeah. So when I'm using homologizers, so okay, this is what I was just trying to give a difference. Okay, now homologizers are the ones which are easy for use in a structural equation modeling. There is something called as multi-group analysis in structural equation modeling. Okay, so in that sense, I can make use of a homologizer there, because that can help us in figuring out whether there is a difference in a relationship between the groups based on which I have made the structural model. Okay. Now, to explain this about how do I use moderation in a structural equation modeling. Okay. So let me take you to one more web link. So let me share my in the chat box, so you can have a look there. So tinyurl.com semshine -kb. Okay, so I just shared the link with you in the chat box, so you might like to go through that. So I'll just try to explain the multi-group analysis. So let me just use the same here, tinyurl.com. /semshine. It is a different link than the one which I sent you earlier, because here I've given some facility to do multi-group analysis. Okay, and there is one built-in example which I have used here, so that I can show you the multi-group analysis in structural equation modeling. Okay. Now there is a built-in example. You can even download the data set. That option I have given here, so you can download the data set by clicking on that, and you can see the data set for your data set for your reference. That can be done. Otherwise, you can have a look here. You see, basically this is a data set which again, this is a classical data set called Hallsfield and Gunsfold data set. Okay, so basically I'll just explain you the context of this data set. Now there are some indicators which you can see here from x1 to x9. So these variables are indicators for three types of competencies a student in a school should have, right? So, or basically their strength of visually analyzing things or writing part. So you can see here visual, textual, and speed. Okay, like how quickly they can visualize or how quickly they can write or communicate, and in overall the speed of understanding. So there are some, in this data set, there are around 300 records, right? And these 300 records, you can see the number of observations is 300. And there are totally 15 variables which are there in this. Okay. So out of that, 9 variables are the ones where they are denoting their scores on a scale of maybe 1 to 10. I'm not sure the exact scoring part here. So these are certain scores which they are provided on some 9 different examinations, can say that. And the first 3 were visual competency tests. Then the X4, X5, X6, they are the ones which were related to textual thing, or possibly the writing part, and speed was a speed test kind of thing. So that means how fast they can solve some problems. That might be the case. Okay. So these were some certain tests which were carried out, and these 300 students who belong to different schools and of course different genders were considered in this model. Okay. Now have a look here that we have these things. Now I'm trying to explain as in as simple way as possible. Actually, you can use this for any multi-group analysis if you want to. These results are easy to use, and this is very easy to operate. It is on the same lines as how we discussed in the previous session about how do we specify our model, right? So now here, just have a look that let's say I'm looking at a multi-group SCM model. Okay. Now in a multi-group SCM model, I have 3 factor model, which are placed it here. Like visual, it is indicated by X1, X2, and X3. Textual, it is indicated by X4, X5, and X6. Speed, it is indicated by X7, X8, and X9. Okay. And then I also suggest that speed is getting influenced by the way the speed in the problem solving is influenced by the way they communicate, that is textual, and also the visual competency. So this is my structural model which are used in general. Okay. Now what I want to see is, does this depend on gender? That means, can I say that if I bring in gender, does my equation change either in its form or intensity? Right. So that is what is our logic which we are trying to develop. Okay. Now using a multi-group analysis is easy here, because what I can do is I simply use this multi-group, check it, and then my grouping variable, I can consider the gender. In this case, I have listed the grouping variable, the moment. So all these are categorical variables. So let's say here sex is actually gender. Okay, so I use sex as my grouping variable. Right. So you can see that here sex 1 and 2 is given. 1 is male and 2 is female. Okay. So when I look at my structural model based on multi-group analysis, and my grouping variable is sex. So now I will be getting 2 structural equations based on this. So if you see the model summary, okay, it gives you 2 different structural models for each group. So you can see that there were 145 males and 155 females, because the 1 and 2, right? Number of observations per group. So my sample size itself has now got split. So it is as good as running 2 separate structural models for the male group separately and the female group separately, right? And then look at the equations. Okay. So you can see here, I have certain estimate being mentioned for the male group, like how they are getting affected. Or actually, you can see here that in the male, the speed doesn't depend on textual, right? You can see the p-value is quite high, indicating that the speed is only depending upon visual in case of male, whereas in case of female, you can have in female. Again, in female also, it's sounds like the speed is not depend on textual, but only based on visual in general, right? So in both cases, you see that the relationship seems to have the same form. That means the speed is dependent on visual, but not on text. Okay. However, now let's have a look at whether we have the same intensity. Okay. And this is where we may consider the relationship, how it looks like. Of course, I don't have a standardized estimate here. So maybe because of that, sometimes my result can get affected. Okay. But let me just get a quick idea from the unstandardized estimate only. So suppose I see that here my estimate for visual in case of male, it is 0.225. Okay. Whereas in case of female, it is 0.304. Now, what does this mean? How do we interpret this? You see that there is more value of an estimate in the case of a female for visual. That means the relationship is more stronger in case of a female when it comes between visual and speed, whereas it is less stronger in case of a male. Okay. Now this is what we have got from here. Like both are impacting the speed, but in case of female, the relationship is more stronger. Okay. Now this is one of the interesting observations. Like perhaps like now here you can write any story on earth to justify this. Like maybe you can say that females are more obsessed with visualizations, and that's why they easily understand visualizations, and thereby it is helping in speedily solving their problem, right? So that could be one justification which you can give. Okay. So this is how you see you can write some extra discussion, like you get a masala here when you for your research papers. Okay, so you do a multi-group analysis. Actually, you are doing a structural model separately for two or three different groups. Like in this case, it's two different groups. So when you get two different groups, you have got two different structural equations. And if you get there are some subtle differences between them, then of course that is a rich discussion you can write. You can start commenting upon why it is like that and so on, right? So like here, I can just like I'm just throwing some words out here that women might be good at understanding pictures rather than men. in general, and that's why possibly the impact of visual over on the speed of the problem solving is more in case of females compared to males, right? So this is a multi-group analysis which is much easier to do in structural equation model. Okay, and that's how we consider a moderation analysis in structural equation modeling. Now, using a quantitative moderator becomes immensely problematic and very difficult to solve in structural equation modeling. So usually people do not make use of quantitative moderators in structural equation modeling. So using a qualitative moderator is always easy through multi-group analysis. You can carry out the moderation activity in structural equation modeling. So any questions at this stage? Is this clear? Yes, any questions? So you can even actually see there will be two visualizations, or at least if you closely look at the visualization here, you will see that there are two groups of things which would be mentioned in the visualization. Okay, so of course this if you need to expand this to have a clarity. Yeah, so this is a multi-group analysis. You can see there is a triangle which is drawn. So it just indicates a certain group number inside. I'm not able to see it with my hands, but maybe once you download, copy paste it and expand this, then you might be able to see it properly. Okay, so this is my multi-group SCM. Okay, right. So you can download this. This is just a way how you can carry out multi-group analysis in structural equation modeling. Right. Any questions before I move to mediation? Because yeah, so this is what I have to say for moderating activity, moderating variables. So any questions on moderating variable? So shall I proceed?
So one example of moderating variable in this regard, for example, x1 to x9.
Yeah, just now I said. See, here the grouping variable itself is a moderating variable. Here the sex which I mentioned, the gender, that is a moderating variable. Because you are getting two sets of equations. You will be getting, see, we have got this equation here, right? This equation we will be getting for two groups. So now then we'll examine these two groups and see which group has more estimate, or if the model fits are different, that also we can check, right? So even if you look at the model summary, you see there are two different things you get for each statistics, right? For each of the different models, you are getting different statistics. The model fit would be, you can check from the model fit itself that in the first case, you are getting this. In second, so you know that from here itself that there is two different model fits, right? Because for the first group, the male group, you are getting the test statistic different. For the female group, you are getting a different test statistic, right? So that itself is giving you an idea that here there would be certain differences. But then you want to locate it in the regression equation. What are the differences? Now, in this case, in both the cases, textual didn't matter, right? Textual didn't matter at all. So we figured out that
covariances in the table, visual text, covariance estimates.
Covariance is just that we are saying that there is a connection between visual and textual. That's all. Covariance is here. The covariance is only indicating that they are so they are not totally related to each other. So visual and textual, they are related to each other. So that has been considered, and that's why it's becoming significant. So covariance is just a relationship between the independent variables which we have here.
Okay, good, got it, sir. Thank you.
Okay, so moving ahead with mediation. So I'm just okay. One small point which I have to mention about moderation. So from the slide I could just get that. When can you use some variable as a moderating variable? Again, this is a very fundamental question. So I have one small answer for this with an example of a particular paper here. Like now this is one paper from Raghunathan and Raghunathan in 2008, where they have considered I'm sure you'll be able to understand this. You see, they have considered techno stress creators. So it is about techno stress, that is stress due to technology. It is affecting the job satisfaction. So if there is a more stress due to technology, then it is negatively affecting job satisfaction. So if there is more stress, people are getting more dissatisfied. Okay. So now, if somebody is taking some organization-wise intervention, okay, then that type of interventions can be considered as a moderator. Okay. Let me again give an example, say in the context itself. Like now, JIS University is conducting a research methodology workshop, right? Now, because possibly the focus is on preparing the faculty members and PhD scholars for properly for research methods. So that might be the objective of JIS University. So now the organization is taking a step for all the faculty members and researchers at the university. So that means this intervention is at a university level rather than for an individual person, right? So now this step itself, like suppose we are trying to compare the multiple universities taking this type of initiatives. So this itself will become like a moderating variable. like organization support. So like in your case, it will be the university support for research. So that university support for research itself becomes like a moderator, because that is a intervention which is working for every individual. Like in this example, when I talked about technostress inhibitors, now the organization might be taking some step to make the person feel comfortable, irrespective of how much stress they get from individually from the technology. So this technostress inhibitor is basically a organization-wide step for different individuals to mitigate the technostress, so that they do not get dissatisfied by the job because of technostress. So such type of variables can be considered as a moderator, because it is acting at a global level for all the variables, and so it can act like a catalyst or a so this type of relationship can be considered, like here technostress inhibitors can be considered as a moderator. So in general, what I can say is that when there is a individual unit of analysis and there is a variable which can work at the organization level, then that organization level variable can be considered as a moderator. Okay, so this is what I just mentioned here. The common group interventions for the entire population serving as a catalyst can become a moderator. Okay. Right. Now moving ahead to the next part is what is the mediating variable. Okay. Now, mediator, as the name itself suggests, it's more like a pacifier, I can say, or in some cases it could be considered as a translator or a pacifier. Okay. Now, mostly as a not even as a pacifier, yeah, you can say as a translator. So somebody translating some things for the other person, like just like how we have foreign language translators to have a communication between two people who do not know each other's language, right? So in the same sense, we can have a translator between independent variable and the outcome variable, right? So having a look at the structure itself, you can see that it is coming somewhere in between, right? So you are placing your construct or a variable in between, right? So that's why it's called a mediator. So something, a middle person or a middle person is called a mediator. Okay, so whenever there is some kind of again what we say, fight between two parties, somebody is coming in between and trying to pacify, saying, okay, please settle down, right? So those people are acting like a mediator, in sense that they are just trying to see what one person wants to say to the other and translating them in a way they can easily understand, right? So that is the role of a mediator. Now, mediator is compared to moderator, it is easier to implement. Why it is easier to implement? Because it doesn't look at affecting the relationship, but it is just trying to take the relationship from it's not going to change the relationship, but it's just trying to translate the relationship in a more effective way, right? So that's where this implementation of a mediator becomes much easier. Okay. Now, what can be a mediator? The fundamental question: what can be a mediator? So a mediator can be something which is able to explain things in a much better way. So if you see here, again coming from Baron and Penny, where they mention, so a given variable may be said to be a function as a mediator to the extent that it accounts for the relation between the predictor and the criterion. It can explain how external physical events take on the internal psychological significance. Okay. Now, though it might seem very on a different level when we speak, because this again has come under Journal of Personality and Social Psychology, right? So, but let me explain what, try to explain it in a very simple way. Okay. Let's say, like using some new technology, right? Now, why will anybody use a new technology, for instance? Now, yesterday itself, I think somebody asked whether JASP is free to use. So then I mentioned, yes, it is open source, it is free to use. And probably that is the reason why I'm using it, right? So let's say I have a technology in place, and then it has certain features, okay? And I'm using that technology for a long time. Now, if somebody asks you why, or asks me why I'm using certain technology, like for instance, why I'm using JASP for my structural equation modeling, then I say that it is very easy to use and it is free. That's why I'm using it. So you see, there are some characteristics of that tool which is suggesting that it's easy to use, and it is obviously free. That's why I'm using it. So now what it means is the characteristics of that software are getting translated into a benefit or a value, and because of that value I'm using it, right? So that's what this sentence means, like explain how external physical events take on internal psychological significance. So just because it is doing the job of a paid software, but at the same time I'm not paying for that, that provides me a benefit. So that benefit becomes my mediator, and because of that benefit I'm using it. So my using is my outcome variable, that benefit is my mediator, and the feature inherent in that software becomes my independent variable. So you see that the feature which it has, that means it has a feature of structural equation modeling, okay, and it is for free, and that's why I see that as a benefit, and because of that benefit I'm trying to use it. So this is the journey which a mediator usually takes up, right? So independent variable has some characteristics. Independent variable is just narrating some characteristic. That characteristic is getting translated into something which is psychologically inside, and thereby that psychological insight which we get is affecting the outcome. Like the outcome in this case is usage, right? So this is the trajectory which a mediating variable will use. Okay. All right. So it's very simple to understand in that sense. Again, there are different types of mediators, and something which is discussed again. This particular paper, they, of course, they were challenging some of the aspects which Baron and Kenny had said about mediation, right? So, but it's again a classical paper now, because they are the ones they were, for the first time, they indicated that there are some myths about mediation in Baron and Kenny's paper, which can be reconsidered. Okay, so in this paper, they were actually suggesting a different types of mediation. So sometimes what happens, the independent variable may have some relationship with the dependent variable. Okay. However, the mediator does some job of translating, but may not be doing it completely. That means, like say, if I look at this particular figure, I may say that there is some estimate, say C, between the relationship of independent variable and the dependent variable, but my A plus B is not exactly equal to C, right? So A plus B is basically my mediating relationship, whereas C is my direct relationship. Okay, so now my A plus B, sorry, it's not called A plus B, it is called AB. So my AB relationship is not the same as my C relationship, then that is some differences. So sometimes what happens, both might be going in the same direction. That means there is a mediating effect, and that's why there is also a direct effect. Both are coexisting, then and in the same direction. Then we call that as a complementary mediation. Okay. So talking about that complementary mediation, I can discuss more on this in the structural equation modeling. So let me, before I go to the other mediations, so let me go to my the core paper which I started with. Because if you remember, I said that I will reserve that discussion for this session. So let me get to that. Just a minute. Just a minute, please. Yeah. So you see, we did this, and I was saying that H4, I'll be reserving this discussion for now. So information integrity mediates the influence of security on utility. Now, here my logic is that there are some security mechanisms which is ensuring integrity of the information, and because of that, the person is getting a benefit out of the interface. Like this is the logic of, and because of this, I am suggesting here that information integrity can be a mediator between information security and information utility. Okay. Now, please note this, that test, if I like here you see there is a H1 and H2, which is denoting a separate relationship between security and integrity and utility. Now, most often there is a mistake people do, that just because H1 and H2 are significant, that doesn't justify that you have a mediating relationship. Okay, so I hope that things is clear, because H1, even if H1 and H2 both are significant in my test, that doesn't mean here that H4 is implied, right? So we need to test it separately, because mediating test is a separate one rather than adding the two parts with a common link. Right? So I just wanted to make that thing clear, because it should not look, it might appear like that, that if I test H1 and test H2, both they become significant, then it becomes a chain, right? But that is not the case. So that's why we need to have a separate test for mediation. Okay, so now how do I test this? So let me go back to JASP. Okay, let me open up another structure equation modeling right? So now, if I want to test this relationship here, so I'm just continuing with that. So, yeah, now let me edit here. See, one good facility which JAS also has is that you can rename your title. So suppose I want to change this, I can rename this as, say, mediation analysis. Okay, right. So now let me figure out my mediating model here. Now, how do I test this mediating model? Of course, we will follow a procedure. So let me just discuss that procedure for mediation. Right. So when you look at this, so this is what the Baron and Kenny had proposed. So I'm going to follow this procedure here. Okay. So Baron and Kenny suggest that you have to test for 3 equations, where here M is the mediator, Y is the dependent variable, and X is the independent variable. Right? It's focusing on this. Okay. So I go with the same idea. So if I have to say A, for the first one, which the equation which I have to check is keeping the mediator as my dependent variable, and X as my independent variable. Now in this case, my information integrity becomes my dependent variable. So for that, let me again go back to my structure equation modeling. Yeah, let me just copy this content. Because this is something which is common, because we need to have the indicators set up. So command V, okay, and then in mediation analysis, sorry, commands C, and yeah, so I'm just able to copy paste it from there. Okay, so these are my indicators. So now what I have to suggest, I want to just have II to be affected by security, right? So this is my first equation. I need to put, again, go there and just check. Right? So you see, information integrity is my mediator, and security was the independent construct, right? And let me write a give a. So let me write A here. So A multiplied by security. Okay. The next thing which we need is, I want to test the relationship between Y and X. That is, Y here is my utility and X is my security. So utility is and security. Now this is a direct relationship which I am trying to test, right? So the direct relationship was C, right? C into security. Okay. And the next one which we get here is Again, why we have to test with these both of them together. Right? So why testing along with both of them together? So utility now again it may not it will never be again exactly C. So you can have. So let me don't write anything right now. So security plus, okay, I have kept it sec, right? So let me use sec and sec here, sec plus II. Okay. Right. So I'll not put anything here, but yeah, if you want, you can write something else. Say I'll put B into and D into. Okay. And I'll just okay. Anything else which I just have to look at? Just a minute, please. Okay. Just a minute, please. I think I made some mistake here. This is utility is there. Okay. And information security is here. Utility is okay. I guess okay. So I have got the direct effect, right? So utility which is affected by security is a direct effect, and then the yeah I think I made some mistake here. So utility is my 1 minute. Let me just sorry for this. So utility is my this particular relationship which you see here. Utility getting affected by security is a direct effect, right? My sorry, I think I made some mistake here when I was following it. So now information integrity is getting affected by security. Okay. And the next is the utility, yes, is getting affected by information integrity. So you can see this last two equations, they are the mediating relationship. So if I go with back to my paper, sorry. So we see security having a direct relationship with utility. Another test what we are doing is from security to integrity and then integrity to utility. So this is my mediating relationship, right? So now both you are keeping here. So utility is getting affected by security. information integrity is affected. So that is my direct effect. Then information integrity is getting affected by security, and utility is getting affected by information integrity. Okay, so this is my indirect chain, right? So now this indirect effect I can assess and keep it for myself in this. So this is how we write our indirect effect. So your indirect effect is a combination of AB. So it's A multiplied by B. Okay, and your total effect would be the direct path, that is C, so please just note the notation that it is colon and equal to, and the total effect is again colon equal to C into C plus A into B, right? Yeah, so now we are ready to run this mediating relationship. So, and that comes to command enter. Okay, is there anything wrong? It is confused parsing set C this, let's see this thing. Okay, and some error, just a minute. Is this error? So I'm C into set, A into set. I'm just checking whether my names are correct. Set utility, utility. Yeah, looks fine to me. I'm error. I'm confused passing this line. Just a minute. Is there any problem somewhere? Somewhere I'm getting the issue. I might be able to figure out. Okay. Let me just check once more. Okay, this is working. Okay, so that means what was the issue? So if I say C into sec, this is the direct effect. Okay, so this is fine. So there was any issue with what? I. Now I'm going to write my indirect relationship. So A into sec. Okay, so this is also working fine. And now finally utility getting affected by B into II. Okay, I think I might have made some spelling mistake, so that's the reason it was coming up. And now let me write the indirect effect, that is so let me write indirect IND equal to A multiplied by B, right? So this is also fine. And next we had total effect. So total will be C plus A into B. Right. Okay. So sorry for a little delay because there was somewhere I got some error in that. So that's why. Okay. So now you can have a look here that we what we did was that we set up a direct relationship to start with, and then we followed the indirect relationship path, how it sets up. Now, how do we test for mediation? So we have to just test that whether my indirect relationship is significant and my direct relationship is also significant, right? So that's where we look at the reason why I wrote A, B, C and all other things is that we can actually get those regression equations easily here in the regression coefficients table, right? So if you see this, I know that utility affecting getting affected by security is a direct relationship, and this direct relationship is C, right? Security getting affected by utility, and you can see that it is significant. That means my direct relationship is significant, right? Now let me consider my indirect relationship. Indirect relationship, it has been calculated. Where is it? Why it is not showing up? It will be there in the estimates list, I guess. Yeah, so you see, so the indirect relationship is here down. So in this indirect relationship, you can see the indirect relationship is also calculated, and you can see that it is also significant, right? Now, and both the directions are on the right, the positive direction, and this is how you test for your mediation in structural model. So you can see that I created these parameters through which I could get the indirect effect. So IND is my indirect effect, and I'm getting the relationship computed here. Okay, and I am getting even the p-value. Now this particular test is also called as the Sobel's test. So when you check in the literature of testing for mediation, often you will get this Sobel's test. Sobel's test is nothing but the test of a indirect path through the mediating or the mediating path. So as you look at the part here, my indirect path is actually going through H1 to H2, right? So that means it's a complete path right from information security to information integrity to interface utility, right? So this is the path which we are trying to assess in contrast with the direct path which is here shown in H3. Okay, so what we are trying to justify here is that the if the direct path is significant and if the indirect path also is significant, then that is a case of a complementary mediation. So this is where I said that sorry, where was it? Yeah. So this is the case where I said complementary mediation. So a mediation, a mediated effect where we have the indirect path and the direct path both having a significance and pointing at the same direction. Okay. Now, so this path is called the complementary mediation, and this is how we tested. Now, in case, like in my example, I got both mediating effect and direct effect as significant. That's the reason I put up that case as complementary mediation. But sometimes it might so happen that my direct effect may be insignificant. Like here, my direct effect was shown by C, right? Yeah, the direct effect was shown by C. That would have been, suppose this was insignificant, but my indirect path was significant, then that is a case of pure mediation or complete mediation by itself. So full mediation or partial mediation. Full mediation is a case where we say that my indirect path is insignificant. Sorry, direct path is insignificant, whereas my indirect path is significant. But if both the paths are significant and both are in the same direction, then we call that as a complementary mediation. Okay. So sometimes, of course, I've never seen that such a case, but there are some cases, it seems, which talks about competitive mediation. That means I've never come across this case though, and I can't think about an example for competitive mediation. Like the case where the mediating effect exists and the direct effect also exists, but both are in a opposite direction. Something which is I cannot think of an example, but they said that there is a possibility of a competitive mediation where the indirect and the direct path, they are in a completely different direction. Okay, so and both of them can coexist. Okay, so that is something which I still have to think of an example. I could not think about it, right? But certainly complementary mediation is what I have given you in my example use case. So I have both direct effect of security over utility and an indirect effect of security over utility through the mediator information integrity, right? Yeah. So, but there can be a case where there is an indirect only mediation, which we also call as a full mediation or the pure mediation, where only the indirect path is there. That is, this AB path only is there, but the C path becomes completely insignificant. Right. So this is in a nutshell about the mediator. So let me conclude saying, okay, so now there is often a variable which is confused with mediator and moderator called control variable, right? So I just wanted to give a quick glimpse on what is a control variable. So a control variable is something which is not part of the data analysis, but if you omit that variable, then it might result in an erroneous result. Okay, like for instance, like here they mentioned about scale of business, industry group. Now these are the ones which if you omit this while doing some analysis, that might affect the result final results, and you may get some erroneous results. So what are control variables? So control variables are the independent variables. They are neither mediating variables nor moderating variables. They are independent variables which should be considered for a proper result, but need not be used in your results or analysis. Okay. So most often when we are trying to check a phenomena, like if I want to see what is the effect of training on performance, and I do not take into consideration which type of industry we are talking about, then I might get some erroneous result. So if I do not keep a control, so that means I need to include a industry variable as an independent variable and use it as a control variable as well, because unless I put that, then I might mix up some results of that relationship between training and performance, right? So that's why control variable, but control variable is not a mediating variable and it's not a moderating variable. Okay, so mediating variable, as you can see, that it's a middle level variable, whereas a moderating variable is, as I told you, that it is introduced to affect a relationship either in form or intensity, right? Whereas control variable is a independent variable which is which should be included to have the right results, but it is not the variable of interest to us. Okay, in terms of research. Okay, right. So as a final word, like how do I understand these things? So I'm going to close it with an example which might be very appropriate for this workshop, right? So if you look at this example, and with this I'll like to close this session. So have a look at here, that here I'm saying that there is a research performance, for instance. Also possibly most of you can connect with this particular model which I was suggesting to clarify between control, moderating and mediating variable. Okay, now you might have seen that in some institutes, and probably I'm not sure about JIS University, but probably there is some incentive scheme for performing well in research, right? So like for instance, in our institute, we do have some incentives for getting published in a journal or a B journal. So for various journals, there are different incentives. So if I place that as a in a model fashion, so incentive is leading to some research performance, right? But how do I explain incentive being leading to research performance? Because it motivates the person. So you can see the motivation becomes the psychological translation of incentive to research. So motivation can be a mediating variable here, right? So motivation can be mediating variable which should affect the research performance. Okay. Now, but again, is it good enough for me to be motivated because of incentive? I should have some capability of writing a research paper, right? So based on my capability and my motivation, it can affect my research performance, right? So the motivation, though, might be very strong, but if I do not have a writing capability, then that might again affect my research performance. So this relationship may get affected because of my writing prowess. So now this recency of the topic or the writing. So even if I'm a very good research writer, but if the topic is very stale, then that might affect my chances of getting a research output. So that's how you can consider that these are the ones we can consider as the moderator, like that. That's why you see this relationship is affecting. So this variable is affecting the relationship between these two. Okay. Similarly, what about incentive and motivation? It can get affected because of research policy. So sometimes what happens, there is some criteria based on which only you will get incentive. Like suppose research policy says that only the first author will get the incentive, not all the authors. So then it is a research policy. So even though there is an incentive, but because of a research policy, it might hamper their motivation, right? So that could be another case which can be considered as a moderator. Okay. Now, for talking about control variable, you see incentive is actually affecting research performance. You agree? But that also depends upon who will get affected by that. Like, so you see the stage of a career or academician, like somebody who is at a very like at the age of retiring, they may not get motivated because with incentives, or might be possible that there might be a seasoned researcher, so they don't need any incentive to be motivating them, right? So they can still go without that, right? So it depends upon for maybe young researchers, a monetary incentive might be resulting in higher research performance. But for a seasoned researcher, they may not need any incentives to make a mark in the research performance. Or maybe age factor can also might come into play, right? So this is a good example of a control variable, right? So like in a nutshell, I'm just trying to give you an idea about what can be used as a moderating variable, what can be used as a mediating variable. So here motivation is a mediating variable, whereas anything which is capability or organization-wide policy, that can be a moderating variable. And what type of sample we are talking about, that can also become like a control variable, right? So this is in a nutshell, and I hope I was able to give some clarity between these variables and how you can use it in research. So if you have any questions, I'll be happy to answer them. So with this, I'm done with my session. So if there are any questions, please let me know.
Audience, do you have any questions? Sir, can you share your email ID with the participants so that if they have any issue, they can later on get back to you. You can type it out in the chat box.
Yeah, I've done that.
Yeah. So audience, please note down the email ID of a respected professor. So if you feel that you have any doubt or any kind of difficulty while working with your research on the areas what sir has taught in today's session or yesterday's session, so you can definitely get back to sir. And since now we are running short of time, so on behalf of the School of Management Studies, JIS University, I am highly indebted and thankful on behalf of my entire team to Professor Dr. Kartikeya Bolar sir for his value added inputs to make this session very fruitful and contributing so much to our knowledge. We learn new things. Generally, as researchers, we are focused towards SPSS and AMOS, which I've already said yesterday. But this is something new which we had learned, and learning new things is always creates better learning. And from the bottom of my heart, I thank sir for his efforts, Herculean efforts for the last 2 days to keep us engaged and continuously contribute towards making this session so effective and contribute more towards our learning. So on behalf of all the participants, the management of this institution and the faculty team, I would like to thank sir once again from the bottom of my heart, and please give a round of applause to sir.
Thank you.
So sir, we would like to see you here in physical mode once you are there in Kolkata or when you are free. We would like to hear from you and we would like to listen to you, interact with you in person. And that would be our privilege and rare honor to have you with us in a physical mode. This time we could manage this session in the online mode because of the paucity of time and all the academic events going side by side. Even the end semester exams are going. So in that regard, we would organize a similar program, and definitely we will be having you in physical form. And there, our research scholars and the participants would have a bigger opportunity to learn by person, learn hand to hand from you, and it would be our rare privilege for that opportunity. So
Sure,
thank
I'm
you
looking
once
forward
again,
to
sir.
this. Thank you so much.
Thank you once again. So we have come to the end of the session. Can we have a group photograph? Audience, can we have a group photograph before we close? Can all of you switch on the camera? Yes. Very good. Thank you so much. Thank you, sir.
Yeah. Thank you so much. Thank you so much.
Thank you. Thank you.
Thanks, sir.
Thanks a lot, sir. So dear audience, we have come to the end of today's session. And tomorrow, instead of 11 a.m., we are going to meet at 10 a.m. sharp, and the details will be shared in your WhatsApp group. Thank you. Sir, with your kind permission, I am ending the session.